Okay, this is 7th grade math, second semester, Unit 1, Lesson 1. Vocabulary review. List 5 inequality symbols. Nima, thank you. Less than, equal to. Greater than, equal to. Less than. Greater than. And this is the one that threw the last class off. Can somebody help her out? Gabby? I think you're drawing it. What's the name of that? You're drawing an arrow. What do you call that? You were drawing it. You went like this. Yes. So if I draw what you're describing, it's an equal sign with the cross through it, and that is not equal to. Okay? So very good. So you knew what it looked like. You just need to know what it's called. All right, so those are the 5. Now, do you guys remember how to graph inequalities? So it's not going to go away. You're going to see this again and again. So last class forgot a little bit, but once we got moving, everybody seemed to recall what was going on. Noah in the back, can you graph for me x less than or equal to negative 3?
Close circle on
nice.
-3 and then you point the arrow to the left.
Closed circle at negative 3 because the less than equal part, the equal part, means it can equal negative 3. And then you're going to shade to the left. Very good. Okay. Can I get a volunteer for number 3? Who's got this one? Mason.
It's open circle.
Nice. Open circle. Nice. Open circle at positive 1.
And you shade to the left.
Shade to the left again. Nice. So it can get really, really close to 1, but it can't equal 1. Okay, and we shade to the left because it's less than 1. Okay, Miranda?
Okay, so closed circle number on 2.
Closed circle at 2 because we can equal to, and shade to the left, so we're everything less than positive 2. Nice. Who's got this one, number 5? Robert?
5 or greater.
Okay, yeah, how are we going to graph that?
Put your dot on 5.
A dot on 5, so it's either open circle or closed circle. What do you mean? Closed circle on 5. Very good. That means it can equal 5. And then which way are we going to shade? Which way is greater, right or left? To the right. Very good. So everything to the right is greater than 5. And we can also equal 5. Who's got number 6 for me? Tata.
Open circle on 1.
Nice. Open circle at 1.
And you shade to the right.
Shade to the right. Okay. Number 7. Who's got number 7? Jameson in the back.
Open circle on positive 4.
Open circle, positive 4. Awesome.
And
Shade
shade to the left.
to the left. Nice. Good. You guys remember this. That's good. I'm excited for when we take that park. I think you guys are going to crush last year's 7th graders. Let me go ahead and read this since we're going to put this in the class YouTube channel. What you'll learn: to identify segments, rays, and lines. New vocabulary: point, line, ray, segment, plane, intersecting lines, parallel lines, and skew lines. That's kind of what throws some people off. We're going to talk about that a little bit. Why learn this? City maps show parallel and intersecting streets. A statement such as West 4th Street runs parallel to West 3rd Street can help you give and understand directions. Okay, so if you notice on the map here we have West 4th Street. Okay, and you could think about that as a line segment because it has an end and a beginning, right? And they're parallel. When they're parallel, what does that mean? Jaden. I understand what you're trying to say. A better definition. A better definition. Better. That's opposite. Opposite of that definition.
Oh, I mean,
Help them out.
There are 2 lines that never cross.
They're 2 lines that never cross. They never intersect. Okay, so let's get that right in our minds. Okay, so question. Okay, a point is a location. A point has no size. You can name a point by a capital letter. Got it? So here we have point A. Here we have point B. These are the ways we name those figures in geometry. Okay, so figures are anything we could represent in geometry, but that specific figure is a point, and that's how we name it, and that's how we draw it. Okay? A line is a series of points that extend in opposite directions without end. So if you notice I have an arrowhead at each end of this line, what does that mean? What does that mean if it has an arrowhead on the end of the line? Nima? No, no, no. Both sides of the line have it. What does that mean? What do the two arrowheads mean? Jaden? It goes on infinitely in both those directions. Okay? Now, you name a line by any 2 points on the line or by a lowercase letter. So I can call this line line N, and it doesn't always have to be the letter N. You might have more than one line in a picture, and they'll have to name each line a different letter, lowercase letter. Does that make sense? Sometimes you'll use points that are on the line to name that line. Now for a line, the order of the points doesn't matter as long as you pick two that are on the line. Does that make sense? So there are infinitely many points on a line. Do you understand? There's always another point I could pick out. Just like on the number line, in between these integers, I could pick something in between, right? Does that make sense? So any 2 points on a line, you could pick a point that's in between those 2 points because they're infinitely small. Now, obviously we can't draw a point that's infinitely small, so we draw a point. But I need you to conceptually understand what that represents. So the way I like to think about it is this, and I give this analogy pretty regularly because I feel like it's some concrete that you can grasp. Have you ever watched like the sidewalk, maybe from indoors, and you've seen like the rain hitting the sidewalk? And then it might be hot out that the sidewalk is really dry, but then you see every single drop that kind of fills in and makes a wet spot on the sidewalk. But over time, you see more and more droplets, and then eventually there's no more dry spots on the sidewalk. Does that make sense? Well, that's kind of how you could think about a line. There's a point on the line, another point, and then you could fill in every single point to make up that line. Does that make sense? So these are just 2 points, but there's more than 2 points on a line. All right, so notice here I can call it line AB or line BA or the lowercase n line N. Now, I think some of you are confusing line with this next one, which is array is part of a line with one endpoint and all the endpoints of the line on one side of the endpoint. So all the points are to the right of the starting point, which is A. You name array using 2 points. The first letter that you use to name array is the beginning point. Does that make sense? I can't use B because that's on the side that's got the arrowhead. Do you see that? So unlike a line, array, I have to use the letter of the point where it starts. Do you understand? So array AB is the only way I could draw that or write that, name that. Do you guys understand? Look above AB. Do you see how I have an arrowhead above AB? Okay, and then up here I had line AB. I had a double-sided arrow on both AB and BA. Do you see that? So here for the ray, when I name it, I only need to put a single-sided arrow, but it's got to be above the letter that it extends indefinitely. Do you guys understand? Okay, see that B is on the side with the arrow? So my arrow needs to be above the B. Do you see that? I can't, there's no other way to name that ray. I have to name it that way. Or I could write it out, ray AB, and then I don't have to put the little arrow above it. Okay? Now, a segment is a piece. You might hear in the news, hey, let's go look at that video clip or video segment. They're not showing you the whole video, they're just showing you a piece of it, the part that is most important. Does that make sense? So if we're talking about a line segment, we're not talking about the whole line that goes on forever. We're talking about a piece of it where it has a beginning and an end, just part of the line. Do you guys understand? So a segment is part of a line with 2 endpoints, and all the points in between those two endpoints. You name a segment by its endpoints. Now here, just like a line, I can name it. It doesn't matter which order I have my letters. I could say line segment AB or line segment BA. Do you understand? Now notice the line above AB on that first notation. There's no arrows. Do you guys see that? Because it's a line segment. It doesn't go indefinitely in either direction. It has a beginning and an end. Does that make sense? Any questions so far? Okay, yep.
So that means it starts at A and ends at
Starts at A and ends at B, or I could say starts at B and ends at A.
And for Ray, it starts at A
And goes forever towards B. Okay, and then for the line, it goes forever in the A direction, it goes forever in the B direction. Or I could say it goes forever in the B direction, it goes forever in the A direction. Or I can just call it line N because there's a little italic N just above it. Okay? Any question? All right, you're going to use this again and again. Okay, so I want to get you guys familiar with this. Now, use the points in each figure to name the figure shown. So what do we call this first figure right here? It's a line segment. Very good. It's a line segment. And we could call it line segment XY or line segment YX. And I tried to color code this so you can see what's happening. Now, what do we call this right here? This is a line. Very good. So here we have a line. And I could call this line GR or line RG, or I can say line M. Do you see that? Okay, yep.
You did a video where you shadowed me in it?
No. Okay, and what's this last one over here? Who's got this last one? It's array, and remember we have to be careful. There's only really one way to name array. How would I name it? Where do I have to start? What letter do I start with? Very good, I like that. You start at the point that's on the other side of the arrow, not on the side with the arrow. So here it'd be Ray JT. So Ray
Can't you like switch the arrow?
JT. However it's drawn is however it is. Now if they tell you to draw Ray, okay, you could draw it in whatever direction you want if they're telling you to draw it, but you have to label it correctly. Okay, because sometimes they might give you this and they might expect you to draw that. Okay, so use the points in each diagram to name the figures. So go ahead, write this in your notes, have this in your notes, sketch it out. It doesn't have to be, you don't have to be an amazing artist to have this. Real quick sketch, and then name it. And let's see if we can get it right. Because it's pretty easy. Once you see these a few times, hopefully you have it locked in. And you don't have to make it a perfect straight line, just really quick sketch.
I thought we were just putting on the names.
Have the picture to go with it. Because come Monday, you're going to need to know how to match these pictures to their names, or vice versa. Okay? Easy quiz on Monday, yes. If you are doing your work to remember these facts. This is a lot of review here. I could want you to be successful more than anybody in the world, but if you don't want it and you don't take the steps to be successful, then I can't, how much I want it doesn't matter. Who's got this first one? Who can explain this first one to me? I know you got this. Joel, what do we call this first figure? Ray what? You can only name it one way. Ray what? PD. It has to be Ray. PD. I couldn't say Ray DP. I couldn't say that, right? Because it has, the first letter has to be where it starts. It can't be on the side with the arrow like Atisha said earlier. The other way I can say that is just with the symbol, with the line and the arrow above it. Do you guys see that? There's a little ray above PD. Okay, who's got this next one? Somebody I haven't heard from would be nice. Jakari, what do we call that? Has a beginning and an end. What's that? It's not a ray because there's no arrow on it. It's got an endpoint on both sides. We've gone over 3 of them. We just said 1. What's the other 2 it could be? Gabby, can you help him out? It's a line segment. And so this line segment, what can I name this line segment? Line segment what? Line segment what? RS or SR. Okay, and then my notation, is, how is it different than what I had over here for PD, Ray PD? How would that look if I just used the notation and not the words? What would it look like? Go ahead. Just the line above it. So I could say line segment RS. That's what line segment RS means, just the line above it. Okay, there's no arrows. Or there's another way to name it. What's the other way to name it? SR, line segment SR with the line above it. Okay, who's got this last one? Marcellus, you never volunteer, so you're raising your hand. I'm going to call on you. Go ahead. Line AV, very good. So this is line AV, or we can also call it what? Line VA. And then we can use the notation. What's the notation look like? Here's my notation here. Here's my notation here. For Ray, it was PD with the arrow pointing towards the D. Here, the line RS is just a line above the RS or a line above the SR. How would I write this out without words for this? AV with double-ended arrows. Or there's one more way. With the double arrows, very good. Easy, right? Okay, now, the example I gave you earlier goes really well with this. So a plane is a flat surface that extends indefinitely forever. And so with the other class, I used a folder to kind of say, hey, this is a plane, right? And imagine a plane goes forever in all directions on this plane. Do you guys understand? That's what a plane is. So a line goes forever is one line. It goes forever in both directions. But a plane is forever in all directions on the same level, if you want to think about it like a level. Does that make sense? No, it's not a square. It doesn't have a shape. A plane, but they draw it that way, just like they draw the lines with arrows. They can't draw it forever. Your paper is only but so wide. Your screen is only so wide. So they use it by saying, hey, you can think about this as the plane, but it goes on forever in all the directions. Imagine this would just slice through the windows, everything, and just go forever. Does that make sense? Okay, so a plane is a flat surface that extends indefinitely in all directions and has no thickness. Just like a point has no thickness, it's like infinitely small. A plane is infinitely thin. Okay? There are 2 planes in this diagram right here. Okay? And if you notice, these 2 planes actually, they're parallel. Do you see that? They look like this. I'm showing you these 2 folders to kind of model the picture that you see there. Do you see these 2 folders? That's what's going on. And so the bottom one goes forever on that level, and this top one goes forever on that level. Now, intersecting lines lie in the same plane. So if 2 lines are crossing, that means they cross in the same plane. Does that make sense? So can I borrow your pencil for a second? Can I borrow another pencil for a second? Let me see that. Actually, can I borrow your? All right. So do you see these 2? Okay. Now, here, do you see that these 2 pencils, they're not crossing, right? If I look above them, they look like they're crossing, but they're not because they're on different levels and they're not parallel. Do you see that? But if I made them parallel, then they're on the same plane because look at this. Do you see that they're still parallel? Do you see that? Anytime I have 2 lines that are parallel, then I could chop a plane through it. Do you see that? So the second I have 2 lines that are parallel, I can slice a plane through those and have them cross the 2 lines. Does that make sense? right? Do you see that this touches the two pens all the way, edge to edge, right? But if I turn it, then I can't have a plane touch the two pencils edge to edge. You see that? They're not going to be parallel. See, do you see that these are not parallel, this pencil and this pencil? Okay, different planes. Like this would be a plane here, it would be different than this plane. Do you understand? But if they're parallel, then I could put them so that they're in the same plane. Does that make sense? So I'm trying to illustrate what they're talking about here.
I still don't get what you're trying to say.
So if you look at this top plane, these two lines are crossing. They lie in the same plane. Okay? If you have two lines that cross, they can sit in the same plane, on the same level. Does that make sense? Okay? So these two planes down here, they're parallel. They can sit in the same plane also. On this bottom level here, those two are parallel. That's a plane down there that they sit on. Now, if they're not parallel and they're not intersecting, they're called skew lines. Does that make sense? Do you understand? Skew means that they might look like they're crossing from different angles, but they never cross. Do you understand? So skew line, if you can have a skew line if it's not parallel and it doesn't intersect. And I think the next example does a good job of explaining that. So let's go to this next picture. So do you see this barn? This barn goes with this picture right here. Do you see that? Okay. So there's some other parts of the barn that we can't see that's in the back. So just for the sake of this example, don't think about what is behind on the back side, okay? So intersecting, parallel, and skew, architecture. Use the information in the photograph and the diagram below to name a segment with the given description. So first of all, let's take a look. We have a segment parallel to AB. So here we have AB, and then in the picture, that would be this right here. A, and then B. Okay, so do you see how AB is right here in my drawing? And then in the picture, do you see that there's AB right there? Do you see that? Okay, so they want a segment that's parallel to AB, okay? Remember, if two lines are parallel, they have to be in the same plane. So what would be the plane of AB right here? And that would also be a plane of GH. Describe the plane that AB and GH lies in. Remember, plane is like a wall. Think of a plane like a wall. A wall can go up and down, sideways, at an angle. Okay, so we have a couple planes making up this building. So describe it to me. What plane has AB and GH in it? Describe it to me using the building. Okay, I'm here. Right. You said it. The front of the building where the door is, that's a plane. Do you see that? And so I have GH is right here, and they're both parallel, and they are also in the same plane. So on the front face of the building, that's a plane. Do you understand? Right? Are we good?
Is A, E, and B skew lines?
No, because they're also on the front face of the building. Do you see that? So you have a good question. So A, B, GH, okay, and they don't intersect, so they're parallel. Okay. AE would be in the same plane on the front face, so that would be in the same plane. So they're not skew. Skew means they're not in the same plane and they don't cross. Okay. So AE would cross AB, so that doesn't work for skew. Okay. But let's take a look and see if we could figure out some lines that are skew to AB. All right. So if you look, they give you an example right here. They said EF. And so here it is in the picture, EF. Okay. Now, if you notice, EF, does EF cross AB? No. Is it in the same plane as AB? No. So that's skew. Do you understand? So let me go ahead and color code it over here. That's EF. Here we have AB. Here we have GH. Okay? There it is in the drawing. So the building is to kind of help you visualize what the model is depicting. Okay, so there are some other lines that are skew. But first, before we get to that, can you tell me what's parallel to BC? So do you see BC in the picture? BC. So here's the question down here. Name the segments in the diagram that fit each description. So parallel to BC. So we're going to go back into my picture. Here's BC, and I'm going to put that in red. And so here is BC. Okay, do you guys see where BC is? And they want to know the lines that are parallel to BC. What's parallel to BC? Parallel to BC. Yeah, give me a line. HD, nice. So you have HD right here. HD, that is parallel to BC.
High definition.
HD. And then somebody in the last class said that too. All right, so then what else? Is that the only thing parallel to BC?
You could go on.
Wait, I heard it. Who said it? EF is also parallel.
And so is
EF is also parallel. Is there something else that's parallel? Not that we can see in the picture though. Like behind the building, there's some other edges that are parallel, but I think that's it. So let's go to the next one. Wouldn't be parallel. Now, what intersects BH? What edge is going to intersect BH? So we have BH right here, and I'm going to go ahead and draw this in black. There's BH. Okay, here's BH. What intersects BH? Well, A and C would be the diagonal from one corner of the house. That's not in our picture. Right? That would be like if inside our room from that corner to that corner would be a diagonal. Okay? So that's not drawn in the picture. So I think I heard it. Who? EH from here to here. That's not one of our line segments. Tata? What intersects BH? What is it? AB. AB does intersect BH. AB intersects BH. So AB intersects it. What else intersects BH? GH, very good. What else? BC, very good, intersects at B. So BC is another one. And then I heard another one. HD. Yep, HD.
Is there one more?
What else intersects
FB?
BH? FB would be this diagonal. They don't give us that one. EB, yes. So EB is another one. Right here, we didn't name that one. So EB does intersect at B. So EB. Okay, so anything else that intersects at B? H? I think we got them all. 1, 2, 3, 4, 5. We have 5? Yep. Okay, skew to AG. So let's go up here and look at AG. Here's AG.
What about AE for the other?
Skew to AG. Remember, it can't be parallel and it can't be in the same plane. And so I already heard somebody say out EF is 1. EF. And let's go back up. Remember, it can't be parallel, it can't be in the same plane. I heard another one. So hold on, a lot of you calling out, so can you raise your hand so I can hear what your answers are? Do you have one that's skewed to AG? Skew? No? Womack, you got one that's skewed to AG? No? Skew to AG, go ahead. AB is in the same plane as AG. Remember, it's on the front face. Can't be in the same plane, and can't intersect. So it intersects at A, and it's in the same plane, so it doesn't work for skew. FC, no, that does work because FC doesn't intersect, and it's in a different plane. So FC does work because it's in a different plane, and it does not intersect AG, and it's in a different plane. So AFC is skew. FC. Do you guys have another one that's skew?
FPB.
Hold on. Shh. Can I get a volunteer? Alexia. DC, nice. This one back here. Wait, now hold on. That's a tricky one because guess what? All the corner edges are parallel. So this one doesn't work, right? So if you think about a box, do you guys see why that one doesn't, do you understand why that doesn't work now? It's not in the same, it's parallel. Remember, skew means it can't be parallel. So think about it this way. This corner of the room over here is parallel to that corner of the room over there, right? So I can make a wall that goes straight across, and that wall would be my plane. And it would. Do you see what I'm saying? So that is not skew. So parallel will never work. So that is parallel. DC doesn't work. Does somebody have another one? Alexis. HD. Very good. HD. Did we already say HD? Nope. HD. That is another one. Yes. Okay. And then any others? Who's got one? Chin. BE is in the same plane because it's the front face. BE doesn't work.
Okay.
Remember, it can't be in the same plane. Jakari, skew, give me one more. DC, no, that's what she said. The corners, so think about this, Jakari, here's why it won't work, and I'm going to explain again. You see the corner of the room that's up right there, that corner of that room that makes where these two walls meet, and the corner where the air conditioning is, where they meet? I can put a wall that goes from one corner to the other that would divide this class into halves. Do you see? And that wall would be my plane. So that doesn't work. Do you see why? Anything that's parallel does not work. So can you come up with one that's not parallel and is not in the same plane? Not parallel and not intersecting, yes. Yep, so you're right. You guys are working it out. Go ahead. BC is another one. Okay, I want to move along because I think now you guys got it. Vocabulary. Blank are lines that are neither parallel nor intersecting. Nima. Skew lines. Skew lines. Okay, Two lines do not intersect. Can you conclude that they are parallel? If they don't intersect, can you say that they are parallel? Yes. Yes.
No.
They have to be, parallel lines are always in the same plane.
Yeah, but
Even if they don't draw the plane, you can make a plane for two parallel lines. But that doesn't answer the question.
no.
Bryce in the back. Right, they can be skew lines. And skew lines, Joel, I'll see you at lunch. Go pick that trash up you just threw and put it in the trash. Go ahead, say it again, Bryce. They can be skew lines because skew lines, right, are neither parallel nor intersecting.
Oh, I thought you said they can intersect, but they can't.
Okay.
Parallel.
The first example, what do we have here? Use the diagram to match to name this figure. What do we call this? Atisha, go ahead.
Line segment.
This is a line segment. Line segment, what do you want to call it? LC. Okay? Or we can say LC with the bar over it. There's another way. Who's got this next one over here? Can I get somebody to do this next one over here? Jeffrey in the back, what do we call this over here? Sorry, Jameson. Go. Line MR. Remember, we can also notate that by putting a double arrowhead line above it. Okay. Right, another way we could say RM. Yep. Okay. All right, so who's got this one over here? Somebody I haven't heard from yet. Cruz. What is it? Line what? Line KE. Very good. Line KE. And the way we notate that is KE with a double-sided arrow above it. Okay, so who's got this last one? Jeffrey, you got this last one? What do we call it? Ray OD. Ray OD. And remember the way we notate that? We put OD, and there's only one way to name it. You have to have a single-sided arrow. You have to start with O because that's where it begins. Now, last set of problems. These are, the last class got a little tripped up on this, so let's read this really carefully. We're going to use this picture right here to answer these questions. Name all the segments parallel to AD. I'm going to draw in AD. Do you see this is AD right here? Okay, who can take a chance to answer these questions? Go ahead. So you said parallel to AD is what? FG? No, that intersects. That's not parallel. BC works. That's parallel. What else? Give me another one. FE works. Is that all? Okay. Everybody agrees that's all? Okay. Name all the segments intersecting FG. Here's FG. All the segments that intersect FG. Who can volunteer for this one? Alexia, go ahead. BC intersects. Very good. What else intersects FG?
AD,
Alexia. AD, very good. Alexia, what else? What else intersects FG? Remember, if it's intersecting, all it's got to do is touch it. It doesn't have to make an X. EF.